All right, welcome to, this is the third presentation for TRiRODS, August 2023. This is Phillip Davis. He's going to talk about his investigation of the iRODS protocol, which has been around a long time, and he's figured it all out. Take it away, Phillip.
Hi, everyone. As Terrell said, I am returning after last summer. Very happy to be working with the iRODS team again. And my assignment this summer was to investigate the iRODS protocol. Just by way of a quick introduction, I'll be graduating this fall with a master's in computer science from Appalachian State. I got my undergraduate in French, but I'm very excited to be transitioning into the tech field. I cycle through hobbies like every 6 months, but these are some of the things I've been interested in recently. So if you want to talk about those, feel free to contact me. Anyway, so I investigated the iRODS protocol. What does that mean? The iRODS protocol is the message-based application level protocol used for communication between iRODS clients and servers. So that could be either a consumer or a provider in either role. But the abstraction that the protocol cares about is clients sending requests and servers returning a response. There are different serialization schemes for this protocol. They both have the same underlying objects, but you can serialize it into either this XML flavored format that iRODS understands, or you can use the binary version of it, which is based on taking C structs at the bit level, removing the padding that C introduces to send those messages, and then reintroducing the padding to interpret them as C objects, or structs rather, on the receiving end. All clients except iCommands use the XML encoding, just because it's much easier to understand, even though the binary encoding is far more efficient. So, but what problem was I trying to solve? There are basically two. First of all, that the protocol was not documented, which is inherently bad because it means that anyone trying to develop an application that uses it has to figure everything out from scratch on their own. This was a situation that I found myself in a couple months ago when I started working on a Rust client, both for school and out of boredom. I wound up having to dig through like individual network messages, and it was very hard. Second of all, some investigation by the iRODS team showed that normal iRODS workloads required a lot of connection and disconnection, and they wanted to figure out how to make that not happen. And in general, we would like to understand how the protocol works now if we want to change and optimize it later. So my first approach to this problem was what you see here. On the left, you see ngrep, which is a slightly gussied up version of TCP dump. And I just fired up the iRODS testing environment and observed what messages normal iRODS operations produced at the XML level. And then on the right, you see my mad scribblings that I had in this giant heap of markdown documents, trying to figure out what every little knob and lever did in the protocol. This involved reading a lot of C code from deep parts of the code base. And in general, it was very slow progress because, as Ganning alluded to, and Nishant, I believe, it's not good practice to get hung up on every little detail, but it did provide a solid foundation for understanding what the protocol was doing. Wound up talking very early on with Corey about the blurry boundary between API and protocol in iRODS. Because iRODS is so plugin architecture driven, most things can be boiled down to an API call. So that's authentication, catalog queries, and basically everything except negotiation over the transport layer that's going to be used. So all iRODS connections startup in TCP, and then the client and server negotiate over whether to switch over to SSL. But besides that, basically everything amounts to what APIs does the server provide and what APIs does the client ask for. Surprise, halfway through the summer, after mentioning this project at UGM this year, Ton Smela from the Utrecht University provided a pair of documents from Mike Wan, who is the original architect of the protocol, appearing to do most of what I was trying to do. There were like a few details that were excluded, but basically I had been rendered completely useless. And so Corey sat down and helped me think about what to do next, which turned out to be a demonstration. So came up with this thing called the iRODS protocol cookbook to solve the problem of, okay, we have this document that provides a lot of useful information about the protocol, but there isn't like copy and pastable examples of how to do this. And this is understandable because, as I mentioned, the only sort of existing documentation is already existing clients like the Python iRODS client. But those people who are writing those libraries are trying to make them as efficient and as maintainable as possible, which doesn't always align perfectly with being able to read something and understand how it works at a granular level. So I tried to fix that by making a Jupyter notebook that shows how to do some basic operations. We're going to demonstrate that right now. But it has minimal dependencies. So there's Jupyter itself and pandas. It includes some documentation about how to get all that set up if you need help with that. I'm going to have to share. Oh, I forgot. The notebook is also in the browser. Can everyone see the Jupyter notebook now?
Yes, it's only on the left. That's right.
Okay. Awesome. So here it is. Basically, cell like this. And it's meant to be, so I developed this connecting to Dockerized iRODS containers through the iRODS testing environment, but this should work on any iRODS deployment as long as you can provide a valid value for host and port. You don't even have to have iRODS installed on the local machine you're running this on. Additionally, so suppose you do know things using the protocol. There is some state that there's actually a lot of state that holds over between cells. But what you can do is jump to this cell in admin using the table of contents. Go here, you can click run all above. And you may have to fiddle with that a little. You can see here that sometimes it gets a little tripped up. I think that's because I haven't changed the host value appropriately. But then it'll run all of these and you can just keep going with the things that you care about. And again, an effort was made to make this as transparent as possible. So here you can see the, plain string version of what will be sent over the TCP socket. And that should hopefully show you how to do what you want to do. So going back to the slideshow, what did I learn? What did we learn? A lot of miscellaneous quirks about the XML protocol, specifically a lot of things with character encoding and white space sensitivity. We learned that it's a fairly loose protocol in the sense that a lot of fields don't have extremely well-defined purposes. So for example, int info is included in all iRODS headers. And in certain contexts, it's an error number. In certain contexts, it is an API request number. In certain data transfer APIs, it just is the size of the object being streamed. And it really just depends on, whatever the source, the particular place in the code base interprets it as. Again, you saw that admin XML object, which was just a bag of 10 arguments that aren't particularly labeled. And so all of that behavior is just defined by particular places in the code and how they react to it. And so in that sense, the protocol is not terribly hard to expand. If you need a new object, you just make it, send it to the server with a particular API number, and hope that it responds appropriately. And so with respect to the issue with connections earlier, as long as you can make an API that maintains a single, transport layer, you can do whatever you want. And this is sort of what Corey has been working on with RC Switch User. And in general, the hope with this notebook is that it has made easy things easy, or that there is an obvious way of doing the most basic level of thing with the iRODS protocol. These are some, so I couldn't decide which of these both serve different purposes. This is an illustration of the request response loop that iRODS spends most of its time in, that is sort of visually cluttered, but helps you see which things are happening in the client and which happen in the server. Here's a prettier version that was made using Plant UML that sort of illustrates what's happening here. Namely, that you have this startup and then you infinitely loop in a request response sort of fashion. And then eventually the client sends a disconnect and everything disconnects. Notably here, these bold things are the types of message headers. So there are one or two, I think, legacy headers that aren't used in iRODS anymore, at least not in any active code paths. But these totally exhaust all particular kinds of iRODS messages that there are, which is part of why it might be pretty easy to extend. Anyway, yeah, thank you for attending the talk. Thank you to the iRODS team for helping me along the way. And yeah, it's been a great experience. Any questions?
Okay, thank you.
I had a question.
Yes.
So can you hear me? Is that okay?
Yes.
Okay. So the Jupyter notebook that you were showing, is that available anywhere, like on GitHub or so? I don't know how Jupyter notebooks work.
So I learned this summer that actually a Jupyter notebook is just a big JSON file that the Jupyter program interprets. But in any case, I think Corey and Terrell and I have talked about, I was sort of finishing things up until the last minute, but in tomorrow and Friday, as I finish up my internship, we're going to work on getting things all packaged and published in a nice GitHub repo.
Great, cool.
So I've got a question. You did this last summer and learned a whole lot.
Mm-hmm.
You knew what to expect, how much the deep end could be deep. Is this kind of what you expected, except for the surprise that the work was already done?
Yeah, I think so. So like I was thinking about this. I feel more like fluent in iRODS and the tools that like Docker and all the things that I use to interact with it, but in the sense that I'm, fluent in English and still constantly making mistakes. So it felt more comfortable, but no less confusing, I'll say.
Well, I think we gave you a harder problem this summer, so
Yeah.
that's good.
But it was a lot of fun though.
Excellent.
Also have a question.
Well, and so your plan right now, I think, is still to write a Rust client. Is that still true?
Yes. So that, well, I've locked myself in. That's my master's project. So
okay.
I'll be working on that to satisfy the requirements for my master's degree.
Amazing. Excellent.
All right. So my question is, so after spending all this time looking at the protocol and how it's put together, did anything stick out to you as far as like how you would go about designing your own protocol or just protocol design in general?
That's an interesting question. So one of the things that was suggested early on was reading other protocol specifications. And I think one thing that stuck out to me from reading those is a lot of them, like the iRODS protocol is obviously like application specific. And because of that, it has a lot of things that are different from something like NFS rods, which was meant to be like independent of any particular application.
Yeah.
Or not NFS rods, sorry, NFS in general.
Yes.
So what does that mean for changing it? Well, I don't necessarily think. I mean, in a sense, it's unavoidable that it takes basically the shape that it has, because of the, like I mentioned, like everything in iRODS is a plugin, more or less. And if you read the spec for something like the Postgres protocol, there's a lot more that's just like baked in hard into the protocol. So I think as far as what it's meant to do, it actually is pretty well put together, besides some, random vestigial things that are just left in there.
Yeah, I agree. Very good. Anybody else? Thank you so much. That's really impressive work for summer. And yeah, we're going to make it all nice and pretty for whoever's next.
Thank
Good.
you all very much.
Fun.